Okay, welcome back to lesson 4.6. This is video number 2, so we're picking up with multiplying complex numbers. So when you multiply complex numbers, you're going to distribute or FOIL. You can almost treat I like it's a variable, even though it's not. It's the imaginary unit, but you can treat it that way. But the only thing is that you're going to simplify. Anytime you see I squared, you're going to simplify it as -1. Okay, because again, I squared equals -1. Because if we take the square root of -1 and we square it, the square and square root cancel, and we get -1. All right, we're going to write the expression as a complex number in standard form, so a plus bi form. So we've got 4i times -6 plus i. Then we've got part b, we'll get to that. So our solution for a, we're going to use the distributive property, and so that's going to give us -24i plus 4i squared, because we just distributed 4i. All right, now we need to replace I squared with -1. And so we'll have -24i plus 4 times -1. And when we simplify, we'll have -24i minus 4. But remember, standard form, you have to have a plus bi. You have to have real before imaginary. And so we're going to write it in standard form. And so we're going to have -4 minus 24i. Okay. All right, so let's see. Let's look at 9 minus 2i times -4 plus 7i. So we're just going to FOIL. And so that's going to give us -36. Well, they did the inside first and then the outsides. That's fine. Plus 8i, and then plus 63i, and then minus 14i squared. So we're going to simplify using I squared equals -1. And so we also combine the middle terms. So 8i plus 63i is 71i. So we have -36 plus 71i minus 14 times -1. And so we're going to have -36 plus 71i plus 14. -36 plus 14 is -22. And so in standard form, we have -22 plus 71i. Okay. Complex conjugates. A plus bi and a minus bi are complex conjugates, and the product of complex conjugates is always a real number. This fact will help you write the quotient of two complex numbers in standard form, because we do not want to leave an imaginary number in the denominator there. We really don't. We want to write the whole thing in a plus bi form. So we're going to write the quotient of 7 plus 5i over 1 minus 4i in standard form. And the way we're going to do that is we're going to multiply by the conjugate of the denominator. If we do that, if we multiply on the bottom by the conjugate of the denominator, we have to multiply on the top by the conjugate of the denominator, so that we're just multiplying by a fancy form of 1, because we want to change the form but not the value. Okay, so we're going to get to FOIL across the top and FOIL across the bottom. So 7 times 1 is 7, plus 28i, plus 5i, plus 20i squared. And then on the bottom, 1 times 1 is 1, and then plus 4i, minus 16i squared. All right, so we're going to simplify and use I squared equals -1. I don't know what happened to their negative there. Let's fix it for them real quick. There we go. Get caught up. Much better. Okay, and so we're going to add 28i and 5i to be 33i. So we have 7 plus 33i plus 20 times -1. And then we're going to have 1. And then look what's so cool. The 4i minus 4i, those zero out. So that's always going to happen when you multiply by imaginary conjugates or complex conjugates. And that is amazing, because that's what gives us something real in the denominator. And then minus 16, and then I squared is equal to -1. So we continue to simplify. So 7 plus -20 is -13 plus 33i, and then 1 minus negative 16 is the same thing as 1 plus 16, and so we get 17. Now for it to be standard form, you have to have imaginary component and real component separated out. Just like it's okay to have imaginary friends, but in your mind, you really have to know the difference between your real friends and your imaginary friends. So we always keep real and imaginary clearly separate from each other. Okay, so we do negative 13 over 17 plus 33 over 17 times I, so that we can clearly see what our real part is, we can clearly see what our imaginary part is, and we don't get them confused, because that's when you got to be concerned. Okay, we can actually graph complex numbers on the complex plane, and for the complex plane, you've got a horizontal axis, which is your real axis, so that's where you're going to plot your A values, your real component values. And then the vertical axis is your imaginary axis, and that's where you're going to plot B. Okay, so that's where you're going to plot B. So we're going to plot the complex numbers in this same complex plane, and we've got 3 minus 2i, negative 2 plus 4i, 3i, and negative 4 minus 3i. Okay, so there's a picture. We're going to talk about how you get to each one of those. To plot 3 minus 2i, start at the origin. Move 3 units to the right and 2 units down. So 3 along the real axis, negative 2 down the imaginary axis. Okay, so negative 2 plus 4i, we want to start back at the origin, and we want to go 2 to the left along the real axis, because that's the negative direction there, and then up 4, and here we go, negative 2 plus 4i. Now for 3i, we don't move anywhere for the real, because the real component would have to be 0. It would be 0 plus 3i. So we don't move to the left or the right. We just stay on the imaginary axis and we go up 3 units. Okay, so if we had a pure real number, like if we just had 1, we just go boom over here to 1. Okay, negative 4 minus 3i, we're going to go 4 to the left and then 3 down. Okay, the big thing you have to remember is that real is on the horizon, imaginary is on the vertical, or on the horizontal, and then imaginary is on the vertical. Absolute value of a complex number is defined to be the square root of a squared plus b squared, because it's going to be its distance from the origin. This is so cool. It's like a little Pythagorean theorem problem, because you're moving a units to the right or the left, and then you're moving b units vertically. So you're always, no matter where it is, you're going to have a little right triangle that has a length of one leg is a and the length of the other leg is b. So a squared plus b squared equals z squared, where z is the distance there. So z equals the square root of a squared plus b squared. All right, so we want to find the absolute values of negative 4 plus 3i and negative 3i. Absolute value of negative 4 plus 3i, a is negative 4, so we've got square root of negative 4 squared, plus b is 3, so 3 squared. So 16 plus 9 is 25, square root of 25 is 5. So the absolute value of negative 4 plus 3i is 5. For negative 3i, that's the same thing as 0 plus negative 3i, so a is 0, and then b is negative 3. So we've got the square root of the sum of 0 squared plus negative 3 squared. 0 squared is 0. Negative 3 times negative 3 is 9. 0 plus 9 is 9. Square root of 9 is 3. Okay, guys, so you have learned all kinds of things about complex numbers. Now you need to practice them. So I encourage you to stop the video right now and then do your problems to try on your own. Make sure that you've done your best to understand them, and then come to class and we will go over those problems to try on your own and then get you started on your rounds. Thank you much. Special thanks to Holt McDougall and Larson for his book and for the sources that they provide. Y'all have a good day. Goodbye.